All right, welcome back. In this video, we're going to introduce this idea of what's called uh, partial fraction decomposition. Uh, Now, to kind of set it up, let's consider this arithmetic problem or this algebra problem where we want to simplify 4 over x minus 2 minus 7 over x plus 5. Right? We're subtracting two fractions. So remember the process. It might have been a little while since you've done something like this with algebraic fractions, but it's the same as what you do with numerical fractions. We need to come up with a common denominator. So, right, we look at our common denominators. First of all, if they needed factored, we'd factor them. That's not an issue here. So we have two factors, x minus 2 and x plus 5. And so our common denominator is going to need both of those. So we rewrite our fractions with the common denominator. All right, and then we look and say, okay, what extra did I have to include? So for the first fraction, 4 over x minus 2, I needed to include an x plus 5. So I go up to the top, and I include an x plus 5. Okay. And then I move to the second fraction there. I had an x plus 5 already. I needed to include an x minus 2, so I include an x minus 2. And once we have our common denominator, we can go ahead now and put our numerators together over that common denominator. So as I'm putting them together, I could write it out as it is now. I'm going to actually go ahead and do some simplifying. So I have 4 and x plus 5. So 4 times x would be 4x. 4 times 5 would be plus 20. Now when I come to the second fraction here, the 7x minus 2, I don't want to forget about that little negative sign there. So I combine that with the 7. That's going to distribute through everything as well. So that's going to make this minus 7x plus 14. Okay. And then we have a few little like terms to put together. 4x minus 7x would be minus 3x. 20 plus 14 would be plus 34. So we get the answer negative 3x plus 34 over x minus 2 times x plus 5. Now when I taught working with these problems, I usually just told students there's no need to multiply the denominator out. But we certainly could, if we wanted to, also multiply out the denominator and have x squared plus 3x minus 10. Okay. And so here we've just added our fractions there. Now, what we're going to be doing in this section is we're going to start with this piece right here. And our job is going to be to figure out what pieces we can write that as. How can we take this thing and decompose it into its pieces? Now you might be thinking to yourself, what sick person wants to do something like that? Yeah. What out there idea is it? Why would you ever want to do this? But it turns out if you eventually go on into calculus, there is a time when we actually need to be able to do that. Take something like this and break it apart. Take something like this and break it into its component pieces. And so that's a task that we're going to be faced with later on in calculus. And so we study it here as well. This is a pre-calculus class, so kind of give you a glimpse of it now, because what will happen in calculus is you'll have to do this process and then other stuff after that. So we're kind of introducing this idea now so that if you do go on, maybe you won't, maybe you will, if you do eventually go on to take calculus, you at least have seen it before, and it won't be quite as unfamiliar to you. So here we're interested in studying this because it does give us a lot of algebraic practice and stuff as well. So the process we're using is going to be called partial fraction decomposition. And what partial fraction decomposition does is it reverses the addition process. It reverses the addition process of adding algebraic fractions. Now there are various ways that you can decompose stuff. There are various ways that you can decompose things, but we're going to stick with a very specific one. There's some ideas, and the process we use says that before we do partial fraction decomposition, when we're dealing with an algebraic fraction, p of x over q of x, we say that the degree of the numerator has to be less than the degree of the denominator. Okay. If not, we divide first. Okay, so if the fraction we're trying to decompose is not in a situation where the numerator is smaller than the denominator, then we do that first. Let me just show you an example. So consider the fraction here, x cubed plus 8x divided by x squared plus x minus 2. So what we do to divide this is we do long division. We do what's actually called polynomial long division. So if you don't quite remember that process, let me explain that to you here in this example. So we take our x squared plus x minus 2, and we're going to divide into x cubed. I'm going to leave a place for the squared terms because I don't have any squared terms, plus 8x, and then that's it. Okay, so remember the process of long division. You divide, you multiply, you subtract, and you bring down. Okay. So here what we do is we do the divide step first. So what that's going to involve is we're going to take and look at our leading term, x squared, and ask ourselves the question, what do we have to multiply x squared by to get x cubed? And the answer is I need to multiply it by x. So I match that up above the x's, and I multiply. So I multiply now. X times x squared will be x cubed. X times x will be x squared. X times 2 will be minus 2x. So we've divided, we've multiplied, and now we subtract because we want those things to cancel out. So what that means is I go through here and change the signs of all these things. Okay, and we combine them. So minus x squared, 8 and 2 would be 10x. And then if we had anything, we would bring it down. This time we don't, so we repeat the division process again. X squared times what will give me a minus x squared? And the answer is minus 1. Then we take that minus 1 and we distribute it over the thing we're dividing by. Minus 1 times x squared is a minus x squared. Minus 1 times x would be a minus x. Minus 1 times 2 would be plus, or minus 2. Minus 1 times minus 2 would be plus 2, sorry. Right, and then we're dividing. So we've divided, we've multiplied, now we subtract. So that makes that a positive, and a positive, it makes that a negative. So then in the end we get 11x minus 2. And that's our remainder because now we're trying to divide x squared into 11x, which doesn't go evenly. So at this point what we do is we take our remainder, 11x minus 2, we write the problem out like this, 11x minus 2 divided by our quotient, our divisor, x squared plus x minus 2. And now we have a fraction that is in lowest terms. We now have a fraction that's in lowest terms, right? The degree of the numerator is smaller than the degree of the denominator, and that's actually the object that gets decomposed. So you may run into a problem or two towards the latter part or the beginning of the homework. All right, this is decomposed. That piece right there, that fraction right there is what gets decomposed now. Okay, so you may run into that a little bit on a problem or two in the homework, and that's the process that we use. We do this decomposition stuff.